Hi, my name is Mike Richmond, and this is a mini lesson for biostatistics. This lesson is particularly for students in Math 221B Biostatistics at BYU, Idaho. What we're going to go over today is quantitative variables and categorical variables and how they differ from each other. So let's first start with quantitative variables. Quantitative variables are always going to be a number. If it's not a number, it's for sure not a quantitative variable. It also is going to be some sort of a measurement. You might be measuring a width or a weight or a speed or a time that something takes, but it's always going to be some sort of a measurement. And the important part about quantitative variables, in order to determine if a variable is quantitative, is to decide if it makes sense to do math on the variable. And I'll talk more about that in just a few minutes. A couple of examples of quantitative variables. You might take your newborn to the doctor and they will measure the circumference of the baby's head, and that'll be a quantitative variable. Might be checking your car speed as you drive, that's a quantitative variable, or you might have a tape measure and you're out and back of your house measuring the length and width of your garden. So those are all quantitative variables. Let's talk about categorical variables now. Categorical variables are always names or labels of something, and these are quite often also called qualitative variables. We won't use that word so much in this class, but you will hear that said in other places. A couple of examples of categorical variables are the color of a car in a car lot, maybe, the brand of the cereal on the shelf at the grocery store, or maybe the breed of a dog. Now, on the surface, the difference between quantitative and categorical variables can seem pretty obvious, although there are a couple of tricks, so you need to keep your eyes open for things like this. Sometimes numbers may not be quantitative variables. For example, let's take a look at zip codes. I pulled out a map of the United States here and I stuck a few zip codes of certain areas on here. First one is Des Moines, Iowa. One of the zip codes there is 50327. Alexandria, Louisiana, 71307. My grandparents used to live there. This one's in Austin, Texas, 78725. And then there's a zip code in upstate New York, a little town called Elmira. It's 14904. I had a job interview there once. This is my home zip code in Gilbert, Arizona, 85234. Zip codes are all numbers, all 5-digit numbers. It's easy to plug them into a calculator or a spreadsheet and calculate what the average is. For these 5 zip codes, the average is 60099.4. I've already got a real good indication that zip codes are not quantitative variables because I can't have a quantitative variable, I can't have a zip code that's got a decimal in it. They just don't happen. They're all 5-digit numbers or maybe 9-digit numbers, but we'll skip that for now. Anyway, so I rounded this to 60099, and that's actually a zip code in a little town called Beach Park, Illinois. It's about halfway between Milwaukee and Chicago, right on the shores of Lake Michigan. So I have those numbers. Can I calculate the average of those 5 numbers? Sure. Does calculating the average of those 5 numbers make any sense? If I were to come to you and say, hey, the average of Gilbert, Arizona, Des Moines, Iowa, Austin, Texas, Alexandria, Louisiana, and Elmira, New York, the average of those 5 places is Beach Park, Illinois. Well, that just doesn't make any sense. We don't talk like that. So this is a good indication that zip codes are not a quantitative variable because it just simply doesn't make any sense to do math on them. So let's look at some other common numerical values that are not quantitative. We already talked about zip codes. SKUs. You ever go to the market and you pick up an item and it's got a barcode on there, it's got a little number underneath that? Quite often those are referred to as SKUs or stock keeping units. They're usually all numbers, but they don't really mean anything because if you took several different items and took the SKU, like you couldn't go take a SKU of a box of noodles and a thing of mushrooms and some tomato sauce and some spices and say, hey, I'm going to take the average of these and that should give me the SKU for spaghetti. That just doesn't work that way. Dewey Decimal System. We don't spend a lot of time in libraries anymore because everybody's got the whole world in their pocket on their smartphone. However, Dewey Decimal System is a system of numbering books in the library, the nonfiction books, and you can go find a category and it'll have a certain decimal number, but the decimal number is just a label. It doesn't really have anything to do with the category at all. There's ISBN numbers. Every book has an ISBN number that's usually 12 or 15 digits, and it's unique to that book. But doing math on those, taking the average ISBN number of several books wouldn't really mean anything. Billing codes. You ever go to the hospital and come home and you get a bill in the mail and it says, hey, we did procedure number 647. and it costs $2,840. And you're left wondering, I have no idea what that procedure is. I don't know if it's just some really expensive aspirin or if it's somebody changing a bedpan or whatever. Anyway, billing codes quite often are numerical values that are not quantitative variables. And of course, phone numbers is another good example. It's very similar to the zip codes. Okay, so that's the first tricky thing about quantitative variables, is sometimes they look like numbers, and they are numbers, and they look like they might possibly be quantitative variables, but in fact they're not. The second tricky thing you need to watch for is it is possible, and actually pretty common, to take quantitative variables and make them, change them into categorical variables, and taking categorical variables and changing them into quantitative variables. So let's look at a couple of examples of how that's done. Okay, so let's look at transforming variables from one type of variable to another. First thing we're going to do is we're going to look at categorical variables and how to turn them into quantitative variables. This is really commonly used in sports. For example, in basketball, maybe every time a basketball player takes a shot, it's either a make or a miss. But we don't talk about it in terms of, well, he made the first one, then he missed the second, then he made the next two, and then he missed three in a row, and then he made three, and then he missed one more. That's not usually how we talk about it. What we'll say is, well, so-and-so shot 10 for 17 for the game. So that'll give you an idea of how good his shooting percentage was for that particular game. So that's a very clear example of taking a categorical variable, the hit and miss, and turning it into a quantitative using a transformation. Same thing can happen in tennis. You might look at first serve percentage. Baseball is very commonly used to change categorical to quantitative in taking somebody's batting average. Instead of saying hit, out, out, hit, out, you say, well, he batted .322 for the season or something like that. This almost always involves taking some sort of categorical variable and summing it over a period of time. Maybe it's a location, maybe it's just some sort of time frame or something. So we usually sum those up. Here's an example. I have a parking lot that's got a bunch of cars in it. They're all different colors. I could go to each car and say, this one's red, this one's blue, that one's gray, this one's white, and I could one by one go through and describe the categorical variable of the color of the cars. But another thing I might do is I might say, hey, in the parking lot, I've got 38 red cars, I've got 31 blue cars, I've got 26 white cars, and 16 black cars. Now, just so you know, I didn't go and count these cars, so please don't count these and say, hey, you counted those reds, and I only see 32. And I think you're wrong. I wasn't trying to match the numbers, just trying to give you an example. This is just a way of taking a categorical variable and making it, using it as a quantitative variable. These quite often will be expressed as percentages too. That's a pretty common thing to see. So instead of saying, hey, the count of red cars is 38, you might say the percentage of red cars is 36.2%. All right, let's look at taking a quantitative variable and transforming it to categorical. This is also pretty common. Good example is grades in a class. You know, in this class, anybody who gets between an 87 and an 89.9 is going to get a B+. So rather than at the end of the semester reporting your score to the registrar, I'm not going to say, oh, Joe Thompson, he got an 88.2% overall grade in this class. I'm going to say he got a B+ in the class. So it's very common in grades. It also happens a lot with lending institutions and credit scores. They won't necessarily look at each individual borrower and say, oh, his credit score is 722 and her credit score is 794. They'll bucket you into different groups. They'll say, hey, you've got poor credit, you've got fair credit, she has good credit, and that woman over there, she has excellent credit. Changing quantitative to categorical variables always involves some sort of threshold values, and then you convert a set of of numbers into these different categories. And I have an example here. It's a little bit more generic. Here I've got a scatter plot, has a bunch of data points. Each single dot is a single data point. And you can see how it has scales on both the vertical and the horizontal axes, so that I could tell you the value for each of those data points based on the scale. And I didn't even label the scales because it doesn't really matter. I'm just trying to illustrate the fact that I can kind of bunch these up, kind of look at, maybe there's some clustering that's going on that I can kind of eyeball it and say, well, this is sort of clustering. For example, I might take this group in the upper right-hand corner and say, yeah, these data points, they all belong to the green group. And then down in the lower left, I might say these are the blue group data points. And then all that stuff in the middle might be the red group. And you can even see a data point in there that is based on my grouping scenario, doesn't even belong to any of those groups. So this was just a brief discussion of quantitative and categorical variables. I hope you found this helpful. If you have any suggestions of what I can do to change this or make this better, please let me know.